anymore, please. Yeah, okay. Jason is joining. Great time. Hi, Jason. Hello. Okay, let's start our meeting. I share my screen first, and then we have probably 8 students finish some sort of project, so that's great. This time is much better than the first meeting. And again, I am David Pan, and we have 2 hosts, co-hosts with me, Jason Law and Yuyan Liu, both volunteers. Since some of you probably is joining this meeting for the first time, so I just quickly introduce myself. I am the director at Youth Coding Innovation Club, and I ask Jason and Yuyan to introduce yourself one by one. How about Jason? You're first.
Yeah, I'm Jason Liu, and I knew David since 2017, and I took some of his classes and I worked on some projects with him.
Great, thank you, Jason. Okay, Yuyan, you're next.
Hi, I don't know what to say again.
Just introduce yourself.
I'm
okay.
Yang, and I'm 13, and I'm going to 9th grade in September.
Cool. Okay. Yeah, both Jason and Yuyan are really good programmer, I mean, at their age. So I'm glad they can serve as volunteer here. And they will demonstrate and explain how the code was designed and it works. And since our coding group, it's not really the class, so we will not really teach the very basic stuff. So in case you have some very entry-level question, you can post in the chat. But in general, we do not really come here to teach you ABC. So that means we don't really teach from the very beginning. We explain how the project was designed and how the code will be running. And we expect you will change the code over the time. Okay, again, quickly introduce, we are Youth Coding and Innovation Club. Origin start at 2015 when I met with some parents, include Jason's parents and Yuyan's parents. In the last 6 years, we have a lot of club members, and we have students and parents from different states, New York, New Jersey, Texas, California, Illinois, and also we have somebody from Maryland and another state I forgot, Maryland and Ohio recently. International-wide, we have members from Singapore, Shanghai, Nanjing, and yeah, that's our club's website. In case you have interest to know more about our club, please come over. Just remember it's .club, not .com. Okay, so this part is repeat, but just in case you missed the first meeting, what coding group means. This summer, we host free coding activity group for those kids who have already learned. What I heard from a lot of parents complaining is that, okay, my son or my daughter learn Scratch and learn Python, even learn Java, but after 1 or 2 years, they totally forgot how to code. They don't really know anything more than the basic. So that's a problem. The problem for any of this skill set, like you play the piano or you play soccer, is that you need practice. So this coding group is really for practice. So fundamental skill set, we don't really teach you here, but we hope you already learned something. And we help you to understand how the project was created, designed, and how the code was working. Last time, Yuyan and Jason have great demonstration, so hopefully you can see how they, as advanced programmer at their age, can explain to you using your language, so you can understand that. Okay, and in our coding group, we break down into 3 different groups beginner group, so Scratch, Broccoli, some sort of language which you're probably familiar with. Intermediate group, it's mostly Python. Some of them use Java. And hardware group, all kind of hardware. I still remember I teach GSM. Maybe you are also in that class, right? Raspberry Pi, that's a very tough class. Yeah, but we did a lot of very fun project. Okay. And the theme for this project is American holiday. Since we just passed the July 4th, right? So we know American holiday have some of this big holiday like the July 4th, Labor Day, and Thanksgiving, Christmas. And so if you see all of this icon, we have a lot of holiday to celebrate. And I hope you can create your own project, and then you can find to celebrate the holiday, you can use totally different way and very unique. Okay, so let's start. I don't waste anybody's time. I hope you can enjoy. This time, it's very fortunate. We have a lot of students at beginner group. They finish some sort of project. Some of this are remix. Some of this are they found by themselves. So that's pretty good. But even before that, I really like to start by the volunteer to explain how the project works. And we start by Jason. So I stop sharing my screen, and Jason, you can share your screen now. Thank you.
Can you see my screen?
Yes, we can see.
Okay, so I guess I'm gonna first start by playing the program.
Yes.
So it starts with the city background, and then every time you click, oh, it's a bit. Hold on. It's a bit laggy, but
that's okay. That's okay.
Usually it's not like that. But like every time you click, it's basically a firework that comes up, and it makes a firework noise. So yeah, and it also changes the color of the background.
Oh, change the color. Cool.
Yeah, I don't know if it's like that for you too, but
I think I saw one time, but not very often. Maybe you are running too many programs on your computer.
I think maybe it's just the screen share because
a little bit. Yeah.
Yeah, I think maybe it's just the screen share because it was working fine before.
Oh, okay, I got it. Yeah, that's odd.
Okay, so first, there's two sprites. There's the rocket itself that travels, and then the explosion. Like maybe you didn't see it, but hopefully you did. It's like a bunch of explosions. So whenever the flag is clicked, that's like when the Scratch program starts, and then it'll loop forever. When mouse down, which basically means you click the mouse, right? And then the rocket will go to the X value, which is the horizontal axis of where your mouse is, and Y value of -180. So it like starts in the bottom over here off the screen, and then it shows itself, and then it eventually glides to the position where you clicked on the screen, which is mouse X, mouse Y, and then it hides. So like, that's just the rocket itself traveling up. And then the rocket will broadcast this message called boom, which gets received by this other sprite, which is called the explosion. So like once the rocket finishes traveling, it'll send a message to this other sprite, and then it could continue from there. So basically, whenever the rocket finishes traveling, it plays this snap sound. And I set the volume to 40% because otherwise it was very loud.
Okay, that's fine.
And also, when the flag is clicked as well for the explosion, it will hide and create 300 clones of itself. So each explosion, let me see if I could play it again. Like each explosion is like hundreds of dots. It's not just one thing, right? So it makes 300 clones of itself.
So actually, this is how the firework looks like, right? Because they are really cloning stuff by 300 pieces. repeat.
Yeah, it's like
right?
300 small circles.
Yeah, small circle, yes.
And so when the rocket finishes traveling, this is when it receives boom, right? It'll set each of them to a random speed. And then ghost effect is just basically like if it's transparent, right? So eventually it'll fade away. All of 300 circles go to the rocket, and then they each go in a random direction. So that's how it looks like an explosion, right? There's 300 circles, but all of them are going in a random direction. So it looks like an explosion. And then they will show the circles, and then it will move at that random speed 50 times. And then it'll do that again, but times 0.9. So basically that just makes the circle slow down a little bit. And then it moves that amount again. And then change ghost effect by between a random number of 1 to 3. That just makes it eventually fade away. So like it won't be there forever. Like as you can see, like eventually the circles will disappear. And yeah, that's how it works.
I have a quick question. So how can this firework really looks like explosion very evenly on different direction? Looks like it's really like 300 different ball, right? But they are not really only on 1 or 2 direction. Instead, they are pretty even distributed on all of this direction. So what's the reason? I mean, or we can guess what's the reason behind that.
Well, yeah, it's basically this block right here, point in direction, and then it picks a random number from -180 to 180. So if you have like 300, or maybe you could change this if you really want 1 in every direction, right? You do like 360. And then the random, if you do it enough times, you should get a pretty even distribution, right? It shouldn't be too much in like one direction.
That's a very cool answer. So basically, if you have enough number, the random should be in a big enough pool, right? So they will go to a random direction, which can cover all of this angle. So if you have enough number, would you mind to change that repeat to be something like 10 so we can see how it works?
Yeah.
Yeah.
So like you can see there's only like 10 circles.
I have 10 circles. That's cool. Yeah. So it's really proves something. So it's still pretty evenly distributed on different directions. Just have few of this firework. How to say that? Dot, right? Maybe
yeah.
Dot. Okay.
But if you put more again, then
that's more.
Actually look like an explosion.
That's very cool. Okay. Yeah. That's very nice. Yeah, it's a great project to start with. Okay, thank you, Jason. And I think Yang can demonstrate the next one. Yeah, if you can stop the sharing, so Yang can start sharing.
Hi. So this is working. I can see it.
Yeah, I can see it.
So here is the program that I'm going to talk about. So I'm going to play the video here.
So are they randomly shoot out, or they are change the angle by mouse or by?
Well, I'll get to that.
Okay.
So we can take a look at this program in steps, so we can see here's where the main part, and then we also have the end screen, as you just saw in the video. So here is the main scene. We have the fireworks that are like moving out, as we saw in the video, and the characters. They don't do anything, but they're just like staying there. There's like no motion. Here's what all the characters do. They basically do the same thing. So when the program is started, they show themselves, they switch their costume, and they move in front so that you can see them. When they receive outro, they will hide and they will stop. Who sends this outro message? We'll get to that later. Also, one of them says Happy July 4th, so right here. Here's where it gets a bit complicated. This is what the fireworks do. So we're gonna set finality to not yet, and then we're gonna choose how long to repeat. First, repeat like how long to repeat. There's two variables for that. We'll get to that later. And we're gonna hide ourselves since the fireworks are only shown using clones. We're gonna repeat the amount of times that we just decided earlier using that random block. We're gonna create a clone. What the clones do, we'll see that later. We're gonna count the amount of fireworks, and then we're gonna set finality to now. Now, what does this finality variable do? We'll also get to that later, okay? So I'm postponing a bunch of things right now, but you'll see. And here's the second part of it. Also repeat the amount of times we decided earlier, except this time with a different number. Here, clone of ourselves, count number of fireworks. We saw this earlier. It's basically the same thing, except repeated twice. And we're going to broadcast outro, which is what the characters received, as we saw in the previous slides. So what do these clones do, right? I haven't talked about that yet. So here it is. It's very large. But if we look closely enough, we can see that this is the exact same two code blocks, except with changed numbers. So let's take a look at one of these. So we're going to set a size to 50%, between 50% and 75%, which gives me random. We're going to make the costume look like a firework rocket, which is costume 2. We're going to move to the front so we can see it and won't get blocked by other things. We're going to move to this position on the stage, and then we're going to glide to another random position on the stage. So it's like going up or that way, basically in all directions. We're going to set the costume to random figure, which is why all the fireworks are not the same. It's different every time. And we're also going to change the random color. And then in 10 times, we're going to change the ghost effect, which makes it transparent. So it's like slowly fading out after we've done everything. And then we're going to hide the sprite. So what are the differences between the two code blocks we've seen earlier? You can see that the size is different. 50% and 75%, 75% and 100%. So that means when the finale variable is set to now, the fireworks are going to be bigger. And the time and where it glides to. So we see if the finale is now, it's going to be gliding faster and also over a larger space. If you see the pick randoms are different, they're larger and larger numbers. And here is the ending scene. Nothing changes except for this moving animated picture or GIF. This is what the ending scene sprite does. When the program is started, it's going to hide itself because we're not ending yet, so we don't show the ending screen. When outro received, we're going to go to 0, 0 to make it centered. We're going to set the costume, and we'll create a clone. We'll see what that does in just a few moments. And then we'll set size to 100 and show to make sure that's the correct size. So here is the ending scene. Here's what the clone does. When started, we're going to move to 7082, which shows where like the animated picture is going to be. To the side, we're going to make it a bit smaller so it doesn't take up the whole entire screen. Go to the front layer, and forever we're going to constantly switch to the next costume, which makes it animated. That's it. That's all the program does.
That's very cool. Would you mind to demo the how it runs? Like, yeah, one more time.
Here it is again.
So basically, the direction is random, or that's something which has been called hard code.
Yeah, it is random.
Oh, that's random. Okay.
You can see the random blocks right there. Glide, pick random.
Okay, cool.
So that's random. Yeah.
Okay, that's very nice. Thank you. Okay, let me see. Let me share my screen first. And I will call out the student one by one to share your screen and demonstrate your project. We start by the beginner group. Okay. And Sophia the cat. Okay, this name is really a very unique name. Okay, are you here? Okay, Sophia the cat. Okay, this is a project what you made over here. If you are not here, I just demo it.
I am here.
Oh, you're here. Cool. Yeah, I can. Yeah, you can try to share your screen, and then I can accept it. I stop sharing, and then you can share your screen and explain your own project first.
Okay.
Are you able to share?
I'm trying to share.
Okay. I didn't see the request. Maybe it's not coming. Okay.
I can share now. 1 second.
Sure. Yeah, when Sophia is sharing her screen, the next one is Kevin Zhao. Kevin, are you here? Yeah, you're next.
Yeah. Okay, I can share my screen.
Yes, we can see it.
Okay, so this is my project.
Change.
So the firework right here is it will just expand like this, and it looks kind of like a bubble. So it makes it look like bubbles inside the city background. I didn't know what to do for this, so I made a fish eye effect. Oh, it's a bit lagging because of the screen share. So this is what I did. So whenever this command goes in effect, then it will make like the bubble effect here, and they'll just keep on going, which I think is kind of cool.
Yeah. So all of this firework are really the picture, right?
Yes, and this one is a GIF, and then it just switches to next costume over and over forever.
Okay.
And this one just appears first as a ghost effect, just fades in. Yeah.
Okay, I got it. So the change the effect, so it looks like the fish eye and change the fish eye again and again, and by every it's at 0.1 second, right? Okay, or maybe
Yes. Okay.
Okay, that's very cool. Yeah, thank you. And let me call next Kevin Zhao. Yeah, so you can share your screen and explain your project.
Okay. So yeah. So when you press like the this, it can, when you press the left arrow, it can go left into the explosion. Up, you can go into the up explosion, and right, you can go to the right explosion. And you can they point in different directions.
Okay.
From the
Yeah,
bottom.
would you please explain your code a little bit? Just show us how this code works.
So it has two costumes.
Okay.
The firework. So when it starts as the firework, so it goes from the box, it points in the direction you want it to point into. Then it will glide into the spot that you want it to glide. Then when it gets there, it will change into the explosion. Wait 2 seconds and hide. It has the up arrow, left arrow, and white arrow for each one of them.
Oh, that's very cool. Okay, so I have a quick suggestion. Yeah, your custom, you probably can rename it. So something like the first custom is rocket, the second one probably is firework.
Those
So you
are
can
the
remember that,
fireworks.
right? Okay, great. That's a great project. Thank you both Sophia and Kevin. And the next one is Azena, right? Am I read your name right? Azena?
Yeah.
Okay, cool. Yeah, would you please share your screen? Yeah, it's very nice. This time we see a lot of kids finish the project here.
Okay, so what I did is just a simple code. So
That's
I
fine.
uploaded a Mickey Mouse PNG image, and the code I did was when green flagged click, I made him say Happy 4th of July. And to be able to make firework noises, I searched up like firework noises free download, and I picked a sound that I liked and uploaded it to Scratch. And I also added 4th of July music.
Oh, cool. Would you please play it?
Yeah. It's a bit loud.
Yeah, I can tell. Oh, that's pretty good. So this Mickey Mouse, and would you please click the flag sprite? Oh, I'm sorry, you already stopped sharing. Okay, that's fine. Yeah, I just want to ask one more question, but it's very, very nice. If you can find your own sound and you can find your own touch up, you can make the project really interesting. And next one is Andrew New. Andrew, are you here? Am I read your name right? Andrew New, I believe. Okay, quote one more time. Andrew New, are you here?
Oh yeah, sorry.
Okay, I see. You mute, so you need to unmute.
Okay, sorry.
That's okay.
So this is, oops. So, so this is my project. Oops. This is my project. So I'm gonna do both of these. So this code is basically so it says when flag clicked. So I just remove the pen thing because I'm not using the pen. And it says go to -5, y -8. So it goes here. And then it says hide. So you can't see it. Like the center, which is the. And then it says change y by 10. So it goes down, it goes up a little bit and go to -46 y -190. Wait 1 second, and then switch costume to costume 3. This one, costume 3, and then it says shell, so it's here, and it says forever change color effect by 1. Repeat 10. Repeat 10. Create clone of myself. And then when I start as a clone, it's so it switches costume to costume 1 because the main sprite is already here. So it switches costume to costume 1, which is like little mini gold. And it says set color effect to 0. I removed the effect because I didn't want it. And it says go to -100 y 0. So it's here, the center. And then it says point and direction, pick random, negative 180 to 180. So it's like a circle, basically, around. And then
That's very cool.
yeah. And then it says show. And it says repeat 10. Move, pick random 10 to 13 steps. I am. And it says repeat 10. Change ghost effect by 10. So you can, as you can see, it's changing its ghost effect. And it says wait 1 sec. Delete this clone. So it can just disappear.
Okay.
The first firework. And wait. And then it says one flag clipped. High. Wait 1 seconds. Forever. Repeat 10. Create clone of myself. It's basically this one but smaller.
Okay. So this one is a smaller one. Okay. May I have one suggestion? I see you use a set color effect. That's pretty cool. So they can really change the effect. Would you able to add the random color so it can be a little bit more interesting?
Okay.
If they change the color, maybe they can look slightly different, right?
Okay. So then it changes color,
That's very cool.
and then
Yeah.
it says go to 150, x 150, y 0. So it's here. And it says point in direction, pick random, negative 180 to 180.
Okay. That's very good. Yeah, this very nice project. Thank you, Andrew. Thank you.
Thanks.
And let me see who's next. And Cassie Chai. Cassie, are you here?
Yes. I'm gonna share my screen.
Okay.
Screen. Okay. So this is my project. I'm gonna open it up.
Sure.
By the way, I'm on an iPad, so which is why
That's
a little
fine.
bit inefficient. First, it's gonna create fireworks, and then it's gonna display the text "Happy July 4th."
Sure.
So first, it's going to completely hide itself. It's not going to hide. It's just going to set the ghost effect to 100. It's going to wait 1 second, and then it's going to create all these fireworks. And then since it's the original sprite, it's going to set its original size to 0. It's going to wait 0.6 seconds. And then it's going to make its size bigger, and then until it becomes Happy July 4th. And it will also create more clones, or basically fireworks. And then how the fireworks work is the X is how much each firework moves, X, and then the Y is how much it moves up or down. So it goes to X0 and Y pick random negative 30 to 30, and then pick a random direction, and then it will move slowly down towards the bottom of the stage and then deletes itself.
So they're pointing to random direction, right? I see it.
Yeah.
That's very nice.
I also have another project that I made a few months ago, pen fireworks.
That's very nice. Yeah. Oh, just one suggestion. Oh, that's another different one.
This isn't really related to holiday, but it just creates a bunch of fireworks. That's all it does.
That's
I'm
interesting.
not going to explain.
Okay. I just have one quick suggestion. Since you built the firework project pretty nice, if you can add the sound in as a background music or some sort of sound, that will be even better, right?
Yes.
Yeah.
Okay.
Yeah, you don't have to do it here. Yeah, that's just one quick suggestion. Okay, anyway, anyone, when you show your project, other kids can really raise your hand and ask question. We are really the coding group here, so that means we really try to code together. You have question, you can raise your hand, ask question. You have suggestion, you can speak out. And it's not really like the homework. It's really the project which you enjoy and you really like to share. Okay, the next one is Juan Wu. Juan Wu. Let me see if Juan Wu is here. I didn't see his name here. Okay, call one more time. Juan Wu. Maybe you used your parents' name here, so it's mismatched. See this? Oh, I'm sorry, I didn't share my screen, right? Oh, Jesus, my fault. Okay, so if you can see my screen, who's finished this project? Juan Wu. Yeah, and also you need to share your project. I cannot really access it. Yeah, you can see here. Whenever you see something like this, that means you finish your project, but you forgot to share. And you need to come over something like this. You already have this. This has already been shared, so that's why you don't have this. I show you quickly. Yeah, if I remix this and I get to see inside, why I don't really see the share button? Yeah, but anyway, you should be able to find one button which show you try to share the screen or share the project. Okay, I think that's pretty much it for the beginners group, and I don't really see any other body finish the project. If I miss anybody, please let me know. Okay, I count by 3. 3, 2, 1. Nobody missed, right? Okay, so we move on. The next is yeah, I put the name here. Actually, I missed one name because you finished today, Sophia. I will put your name over here. I'm sorry, I didn't have chance to change this slide. Okay, the intermediate group. Again, I will ask this time Yan first. Jason will be next. Yan, would you please share your screen and explain the firework project?
All right, just hold on one quick.
Sure.
Here it is.
Yeah.
So this is the fireworks project. Let's take a look at this. So here's the code. We're gonna break it up into 3 chunks, as I did last time. So let's take a look at the first chunk here. So here, we're gonna import the turtle package. We're gonna import the random package, and we're gonna create a new turtle screen. We're gonna change the background color of that screen to black. We're gonna set the color mode to 255. Let's take a look at the second part here. So this is going to create a new turtle. We're going to set the speed to 100, which is very fast. We're going to set the turtle color to red, so it draws in red. And then we're going to make a new variable called style, which will say what the text will look like. So in this case, it's going to be in Courier at 30-point type and italic. And then something confusing happens here. See, we're trying to draw using the color and write functions from this turtle variable, but we haven't created or defined a variable called turtle. So how is this happening? Well, if you noticed earlier, we are also creating a new turtle using the turtle.turtle. Notice that one of them is in uppercase and one is lowercase. So this turtle variable in lowercase contains the turtle variable in uppercase, which can be used to create a new turtle. If you're confused, think of this as the stage in Scratch, right? You can change the background without having to actually create a sprite. So this lowercase turtle variable also contains the functions color and write, and we will change the color to deep pink, and we will write Happy July 4th using the font style variable we created earlier. Okay, so that's that. Let's take a look at the final piece here. So we're going to decide on a random x and y position between negative and 250 for both of them. We're going to stop drawing, move to that position, and we're going to start drawing again. So it doesn't like draw what we're moving. We're going to decide on a random color. And then here's the final part. So we're going to set the size to random number between 30 to 200. And for 36 times, why 36? Well, you'll see later. We're going to move forward and backwards. So we're going to create a line of size, which we decided earlier is between 330 and 200. And we're going to turn left 10. So that makes 36 times 10 is 360. So we're going to make a full circle of fireworks, each 10 degrees apart. And we're going to take a look at what it looks like. So since this is random, I have included like 3 runs of the program, since each run will produce different results. That's the first one. Here's the second one. You can see the circles are different sizes and are in different sizes and positions, and also in different colors. Here's the second one. It's more different. And also the third one is also different. So that's it. That's all there is to it.
So they are really draw 36 times, right?
Yeah. The 36 times make it 360 degrees.
That's very cool. Yeah. Okay. Yeah, I know turtle is really very interesting when you write code for the graphics. Yeah. Do you remember if turtle can support playing back the sound or playing back some sort of pre-record file, like the MP3 file or WAV file?
I'm not sure about that, but I can.
You're not sure about that. Okay. I guess they can. If not, maybe.
Yeah, apparently so. According to my preliminary Google results.
Yeah. Okay, great. Thank you so much. Yeah, you can stop sharing. And then Jason, yeah, would you please share your screen for the next project? Sense had similar simulator firework. Okay, cool.
Yeah, so this is using something called trinket.io, which I guess is a website to like you said, simulate something like this. So what's cool about this is you can directly change certain variables using a slider. So like you could change, in this case, in the code, you'll see you could get temperature and humidity and stuff like that. You could change the temperature and humidity without changing the code. So you could just do it directly with the slider. And so it uses a library called sensehat. And then we also import time because we need that to wait 1 second in between changing each of the firework phases, I guess, right? So these variables, R is blue, R is red, B is blue, Y is yellow, W is white, and G is green. And these are just the RGB values for each color. So red, obviously 255 red and 0 of any green and blue. B is black, not blue. So basically what these are is it's a list of a bunch of colors but like it's in the order of this square right here. So you can use the array to select which color each individual circle in here is. So these are just a couple. It may not look like much like this, but it's basically it controls the color of this simulation.
So
And
it's
then-
one-to-one mapping with a dot, right?
Yeah.
Okay, cool.
And then it loops forever, and it gets the temperature from sense.temperature, which is this slider, like these sliders, right? And it gets the humidity. And if the temperature is less than 15 and the humidity is greater than 90, it will set the pixels to this variable called no fire. So right now, it does not meet that requirement. So right now it's this goes into this else statement, and basically it switches between these three fire 1, 2, and 3 variables, and it continuously loops through them. And that's what you see right here, right? Every 1 second it changes. So it looks like a firework. But then if you change the temperature to less than 15 and you change the humidity to greater than 90, it becomes this no fire one, which is like kind of like a green check mark. And you might actually be able to see it. You could see like the G's form a check shape, and then everything else is W, which is white. So that's what this is. But once you change it back, it'll go back to the original loop.
That's very cool. So actually, this is a simulator of the Raspberry Pi's sensor head, right? So yeah, they try to show that each dot as a LED. The whole matrix is a LED matrix. So they just try to simulate that without the real hardware. That's very
So on the
Okay,
actual
thank
Raspberry
you.
Pi, it would actually have the sensors, right, and detect the
Yeah,
room.
they have the sensor which can really you do not really have to have the hardware to be the sensor. Instead of you have the adjustable, how to say that, it's a scroll bar,
Slider, yeah.
so you can change that. Yeah, that's very nice. So you have the temperature sensor, you have the pressure sensor, you have the humidity sensor, and you can use this. Actually, this one can be used to build a lot of different projects if you have interest in to do that. Okay, very nice. Thank you. And anybody have any question here about the project? I know Python is not sure everybody understands that, but hopefully you can really learn something from here. Again, we are not class, so we don't really teach you how to write the Python code. Instead, you probably get the feeling how Python looks like. Okay, let me see if the intermediate group kids here. Kevin, oh, are you here? Kevin,
Yes.
hello.
Yes.
It's different Kevin.
Okay, would you please share your screen?
Wait, which Kevin?
It's different Kevin. Hey.
Kevin Ho here.
That's not me.
Oh, hi.
Oh, that's not you. Okay. Call one more time. Kevin Ho, are you here?
Yeah, I'm here.
Okay. Would you please share your screen?
Okay.
Yeah, I see Kevin's name here.
Give me a second.
Yeah, Kevin, it's your turn.
I don't think you can share
I
as
can,
long as you're sharing.
yeah, I can screen share.
Yeah, I guess you probably not sharing yet.
Yeah. You have to.
Oh, I have to stop my sharing. Okay, I'm sorry. Yeah, that's my bad. I'm sorry. Yeah, Kevin, will you please share your screen? Yeah, my bad.
So I realized that
Okay, cool.
right now most of our projects is related to holiday. So I made this very convenient generator that makes holidays in Python. So when I press run, it'll show this button for click me for another holiday in US. Once I click on it, it will summon a random generated holiday. Like for example, I have officially made Jeep Day. Hooray! Now on 7/9, we're gonna have to celebrate Jeep Day by drawing pictures of them, coding with them, and also unmentionably steal them on Tesla.
That's very cool. And if you click that red button again, what will happen?
You make it only works once because the button says so.
Okay. Yeah. Would you please explain your code a little bit so we can understand that?
Okay. So so this over here is the Jeep Day code, like this is the picture of the Jeep Day. This is the picture of Flying Day. This one over here is the button. And this one is the one that randomly generates a random holiday from these two over here. Yeah, that's kind of it.
Okay, so you are randomly generate a number and try to figure out which holiday it will go to, right?
Yeah.
That's very interesting. May I give you one quick suggestion? You see you have the draw underscore onclick. That's one function name. Another function name is draw underscore onclick k. Okay, I understand they're totally different function, but basically I try to find what's the difference. It's kind of very easy to get lost. So my suggestion is that you probably like to change the function name, especially the second one, draw onclick k. You change that to be something a little bit easy to remember, or at least very easy to identify. So you can separate these two functions. You do not have to worry about write a function name a little bit longer. It's totally fine. So in Python, Java, or any of this advanced programming language, now the whole point for this function name or method name is that you need to give them the name make sense. So I would suggest you to change at least the second function name. So don't use the onclick k. Instead, write something like draw underscore onclick, maybe flying. The first one, draw underscore onclick Jeep, something like that. So it's much easier for you to understand. Also, if some other people read your code, it's very easy for them to understand. So that's my suggestion. Okay, thank you. Great project. Thank you.
Thank you.
And yeah, let me see who's next. Richard. Richard, are you here?
Yeah, I'm here.
Hello, Richard. Richard Xu. Okay, I call one more time. Richard. I see Richard's name here. So, oh yeah, cool. I see. You probably forgot.
Do you see my screen now?
Oh yeah, I can see it.
Okay. So I just basically like improvised Jason's project. So it's basically the same thing, except I just put cyan as a new color, blue as a new color, and magenta as a new color. And C is cyan, which is here. U is blue, which is right under that. And then magenta is here. And it's RGB colors, so it's basically the same thing Jason used. I just rearranged the patterns. So instead of, I don't really remember what the first one was, but I just made it to some new patterns. So it says 6/4 for 4th of July. And so while true, it's the first three, so like the first three fires, or yeah, the first two fires, it will stop for 0.5 seconds, but the next three fires, it will stop for double that, which is 1 second. That's it.
Okay, very nice. I see one of the file looks like it's number 4, right? Is that what you intentionally make that, or that just happens to be? Yeah, I think 5. You see the file 5. If you check the R, it looks pretty much like the number 4.
Oh.
Yeah, if you see the R, file 5. Yeah. Yeah, if you check, yeah, you can run it one more time. I'm sorry.
Okay,
yeah,
sure.
You can click and run it one more time. See here, this looks like 4, number 4, right? That's, yeah. You probably not really intentionally do that, but it's just coincident.
No, I meant to do that in the number 4 and the 6.
Yeah, this is number 4, right? Looks like number 4. Okay, that's very cool. Yeah, yeah. Thank you. Yeah, if anybody pay attention to what Richard demonstrate and what Jason demonstrate, you can see there are really something different. Is that in Jason's code, we use temperature and humidity to control that, and in Richard's code, it's really pretty much the firework from the beginning to the end. They have different. They are slightly different design. One is really use temperature and humidity to control that. Another one without that. So if you read the code, you probably pay attention to that. Okay. I think we have one more, Max Penn. His name is not really here, but he sent an email to me. So Max, are you here?
Yep, I'm here.
Max, I see your name.
Yep, I'm here.
Okay, cool.
Great.
Yeah, you can share your screen now. Thank you.
Okay, so what I did is I used a turtle trinket and the turtle Python fireworks, and I modified it to become a screensaver. So you can keep this running while you leave your screen on, and it will stay on. So this stays on for forever, and you can leave your screen like this and it keeps going. So how this works is that there's like 3 different kinds of fireworks. So I have type 1, type 2, and type 3. So over here is the setup. So I basically set the thing up, change the turtle, change the background color, and over here I have this loop. So first I have to make sure it goes over here. So the X thing is where it goes over here. But instead of making it a Y so it appears anywhere, I set it so it always appears at this level. So over here is where the turtle sets up and where it starts to shoot up. And then over here, I set up what's going to happen for the type. And then for types, it chooses a random number from 1 to 3. Since there's 3, I can choose 1, 2, or 3. So if it chooses 1, this is the one in the project in the original project. So this is the one where it has lines shooting out. But instead this time, I made the size bigger, and I also made it so it pauses a bit. So I imported a time, and with this time, I can make it so it pauses. Because originally it would like, as soon as it's over, it goes to the next one. But I wanted to make it pause so you can see it before it happens. So if it's type 2, I actually used a turtle like shape. So for the turtle shape, normally it's this classic shape, but I changed it so it has this circle shape, as you can see over here. So then it flashes around and moves around and changes from the circle shape to black. So when it's black, because the background is black, you don't see it moving. So then if I change it to black, it basically acts like a hide, but it's a bit faster than a hide. So that way it looks like it's just a circle flashing while it's actually moving around in squares. And when I change it to 3, it does a flash. It flashes the entire background. And this is the reset, and then it runs the loop again.
That's very cool. Yeah, very nice project. Thank you. Let me see if we missed anybody here. Okay, in case I do not really have chance to call your name, you can shout out and let me know. I'll try to give every student who ever finished the project the chance to make the presentation. The whole point, again, the whole point for our coding group is practice. So you do not have to worry about, oh, if my code is perfect or if my project looks too simple. That's totally fine. You do not have to worry about that. We are not come here to make any judgment. I forgot to put the name of Kevin Ho again here. Yeah, your name is here. I think it's I forgot what. Okay, simulator. Okay, that's simulator. Okay. And unfortunately, most of the kids in hardware group not really as motivated as in the beginner group and intermediate group. I can understand because to create any of this hardware project, it's a little bit more challenge. But anyway, I will demonstrate what I have since the hardware project demonstration will really require a lot of different moving parts. So I show you the video first so you can see how it works. So if you pay attention to that, I guess some of you still can identify what's this, right? This is MBOT. A lot of students take the class and they know what's MBOT. And this actually is a parade, use multiple MBOT, was designed in one of the school. And you can see this is really for the Chinese New Year. So that's the dragon moving around. But if you change it, you can change with the American flag or some sort of the decoration for any of this American holiday. So it's perfect fun. I show you this video just because this gives you some basic idea how the MBOT project can be done. Okay, and then I will show you how the coding part looks like. Again, I don't really expect you will finish the coding here, but I just show you how simple it can be done. I have to make it bigger so you can see it. Okay. So this project is really called the non-follow project. Here it's not non-following, but we can really use the non-following project here. If anybody still remember that, so if you have a black line on the ground, you can use the sensor to detect that black line and follow that line and moving around. The coding is looks like this. So the first one is that you press a button on the board. So they have a button on board you can press. Then inside this forever loop, you have two sensors here. Line follow sensor, I'm sorry, it's connected to one of the port. So they have about four port totally, and the connect port 2. Of course, you can change to port 1 or 3. And if it's 0, then you can moving forward and at certain speed. And if it's 1, you can change the motor on one side to be 0, another side is 150. So that means they will make the turn on this side. And if it's non-follow sensor detect is 2, so that means that they're really over the edge. They will try to make another turn. If it's 3, so that means both sensors do not able to detect anything. They were running backward. Okay, so this is a little bit hard to explain, but this is what really the situation looks like. The sensor is really on the front. It's really like this. So if the detect the mbot is on the black lane, so the value of the non-follow sensor from this two will be 0. And if the detect only one sensor detect the black, another detect the white, so they will return the value as 1, because the value is combination of these two sensors, not only one. And so do here. If you have the first sensor detect is white color and second sensor detect the black color, the value will be 2. Of course, the last one is that if you move or running too fast, totally get out of the black line. So both of your sensor will be 1. So put together, it will be 3. That's why you see the here 1, 2, 3. It's matched to the situation here. 1, 2, 3. So that's a value 1, value 2, value 3. So that means the value 3 means you detect the totally white, and value 0 means you detect the black. If you are really 0, you're perfect. You just move forward. If you are really leaning forward to a right, you need to turning back a little bit, or you're leaning toward to left, you're turning back to the right a little bit. So that's how they control the motor, because the motor is on each side. So motor 1, motor 2, right? So you control each side. Yeah, that's really how it was break down for the line follow sensor. It's very, very important for you to code that part, especially if you want to do some more advanced programming use mbot. I will show you another different video so you can see how it works in different situations. Like here, I will show you the.
Welcome to the 2020 MakeX Robotics Competition. MakeX Starter Smart Links. The competition requires cooperation between the red and blue alliance teams. The Smart Links arena is 2,440 millimeters by 2,440 millimeters, and each arena is divided into an automatic area and a manual area. There are 2 red and blue starting areas, respectively. Robots need to start from their own starting areas. Smart Links consists of 5 independent missions and 5 alliance missions. In each competition, the MakeX Robotics Competition Committee will distribute 3 independent missions and 3 alliance missions. Alliance teams will be assigned the same automatic independent missions. Each game lasts 4 minutes and consists of an automatic stage and a manual stage. The alliance teams will determine the duration of each stage. There is an additional 30-second preparation between the 2 stages. When the automatic stage begins, robots can score in the following ways. 1. Push down the dual cube on the arena. 2. Pass by the obstacle area and make sure the obstacles stay in the initial ring at the end of the automatic stage. 3. Move the balls to the arena. The blue balls represent the blue automatic independent mission score. The red balls represent the red automatic independent mission score. The green and yellow balls represent the automatic alliance mission score. The automatic stage is followed by a 30-second preparation stage. After that, the manual stage begins. During this stage, both teams must control their robots manually to collect balls into the container in the middle of the arena. For each game, the alliance with the higher score will get a higher ranking point in the competition. Welcome to the 2020 MakeX Starter Smart Links.
Okay, so this is really one of the competition which the mbot can use to join and compete. Yeah, if anyone have interest in, you can contact us at the info@ycic.club. again, this is really the beginner level competition, and we have another competition is challenge. It's more advanced level. Next time I will introduce that one, but this one, it's really for age 6 to 13. So most of the beginner, if you are really have interest in, you can contact us. Okay, so again, put as summary, all of this project will be posted on the GitHub page. So I show you how this page looks like, and GitHub. Yeah, so this is our Youth Innovation Club 2021 Summer Coding Group. And if you see that each project, we have one subfolder over here. And I have to tell you, you must share your project, otherwise I cannot download it, so I cannot post here. For anybody share the project, I download and upload over here. So you can see I give the name back, credit back to you, Richard Xu, Max Pen, Asena, you, right, and engineer. And I know a lot of other students also finished project. Please share your project so I can download and I can upload to the GitHub. So that's the very first one. And all of this project will be credited back to you guys. We have the discussing in the Google Classroom, just like here. You saw the question and answer over here. So when you have question, please don't hesitate, just ask a question. And one thing I have to ask Richard to pay attention is that please do not share the code like this. Next time, try to share the code like this. So you can share the file. It's much easier for us to upload the file, download file, because this one will require to make the indent. You know, the Python indent error will cause a lot of trouble. So we do not want to post the code to GitHub without identifying it will work. Okay, so that's some suggestion. And of course, in our meeting, we will ask you to demonstrate your own project, make the quick presentation. So that's everything what you need to do. Again, we've officially finished the second project, that's American Holiday. So we announced the next project topic. Quick question, anybody here play tennis or basketball or play soccer or any other kind of ball?
I play some tennis and I used to play some soccer.
Oh, yeah. Yeah, I play soccer and tennis.
That's very cool. That's very nice. Okay, so you can see we have a lot of different balls here, right? And we have the ball game every year. And if you pay attention to your parents, maybe one of your parents watch soccer, another parents watch the basketball, and another parents watch the tennis. But anyway, if you have interesting about the ball game, that's our next topic. If you have experience about any of this ball game, or if you just like to create a project based on that, please, we need you to participate and create the project using this theme. Ball game is fun. Any sort of ball game, as long as the ball game. So please do not create the project using something like swimming or fencing. Don't create that kind of project. Just use a ball. We have plenty of ball, right? So you can play. You can create football. You can create soccer ball, or basketball, or even ping pong, right? So table tennis or badminton. Any ball game, it's fun. So that's our next project. And yeah, anybody have any question here? Just let me know. This is our contact email. Send to info@ycic.club. Remember, that's .club, not .com. And yeah, anybody have any question or any suggestion here? Yeah, again, I really appreciate both Jason and Yuan, and I also really appreciate all of these kids who finished the project. Even you don't really finish the project, your participation is greatly appreciated. because we really like to build the community here which can practice together and we can share the experience. And you can see a lot of project was really not that challenge, but some other project is really far more complex. So the whole point here is not really try to compete to anybody, say, oh, how good my project is. It's really about how to share the experience and how to build the project and practice constantly. That's why we need to hold on and give you the time period about 2 weeks, at most 3 weeks, so you can finish the project, and then we can put the summary meeting here. So again, remember this project topic, I will post on the Google Classroom. Anytime you have any question, please go to Google Classroom and please post your code as file attached. And yeah, that's pretty much it. Anybody have any question can post over here. We have fun in the summertime and I hope you can enjoy that. Okay, great. Thank you. Bye.
Thank you. Goodbye.
Bye. Richard, I like your hat.